value, which we also kind of talked about how it's like not the most complicated, but it is like we have to use like an equation, so it's not the like most straightforward one. So again, remember to find our C value, we take that B times X minus C, okay, and we want to set it equal to the old value, like from our parent function, and I'm going to plug in the new value from my data. Yes, no, maybe. Do we vaguely remember talking about that yesterday? So remember that yesterday we talked about here, okay, we used a maximum, so we set it equal to pi over 2, because that's where it happens on our parent graph, right? It goes up to 1 at pi over 2 for sine. Now for this one, our new maximum was at 3 pi over 4, so that's what we plugged in. So that process is still going to stay the same. I'm still going to set it equal to pi over 2. The only difference is now, so like we found our B value, so I'm going to plug in pi over 6 for B. And then we also need to plug in our new X value. So again, this is a maximum value. So I'm looking at my depths here. What X value do we get for our maximum? Like, where does our maximum happen? At 4, okay? So that's our new X value. So that's what we're going to plug in for X. There we go, okay with that. So again, I'm setting it equal to the old value, plugging in the new value. Because our goal is just to set up an equation, so now that we can solve. So what do we want to do first to solve for C? Okay, which is the same thing as multiplying by So if I have pi over 6, okay, it's the same thing as multiplying by the reciprocal if I'm going to divide. So I would multiply by 6 over pi. Are you okay with that? Okay, so, which is nice because notice that our pi's reduce. And then how many times does 2 go into 6? 3 times. So we're just left with 3 there. So I have 4 minus C equals 3. What do I need to do next?
Subtract the 4.
Okay, so I get a -1. And then our last step is to divide by a negative. So we just get 1. Now, just like last time, I'm then going to plug all of that stuff in. So my A value we got is 5.6. We found our B value was pi over 6. That C value we just found was 1. And then our D value was 5.7. Okay, we're gonna skip part C. We don't really care about that one for today, but we do want to look at part B. So like we've created this equation that represents our data, or represents these tides, right? And usually the whole point of creating an equation or a model is so that we can then use that to help us predict things. So like predict the pattern, predict the weather, predict stuff that's going on. So it asks us to find the depths at 9 a.m. and 3 p.m. So which one of my variables represents time? The X, okay? So we're going to be plugging in these values for my X, which then makes sense because my Y value represents the depth, and it's asking us to find the depth. Are we all okay with that? Okay, but the nice thing is that we're just going to use a calculator for this. So you're going to be using Desmos for your lab, so I'm going to show you what that would look like. So first off, I'm just going to type in our function. So I have 5.6 sine of pi divided by 6 times x minus 1 plus 5.7. So if we wondered what that looked like, that's what our graph looks like. So we've shifted everything up 5.7, which is why I noticed that like the middle here is just above 5.7, okay? We've also shifted everything over by 1, and then notice that like I have a maximum here at 4, and I have another maximum here at 16. So the distance between those two things is 12, which is what we said our period was. So it is repeating itself every 12 hours. So for the most part, it looks like it's doing it pretty accurately. So on the first one, it asks us to find the depth at 9 a.m. So what am I going to plug in?
9.
Cool. And the reason why I put it in this like function notation is because that does allow us then that I can just say this is 9. Okay. We do want to make sure that notice that I have a pi over 6 here, which is in radians. So you want to make sure that you come over to this little like settings menu and just make sure that you're in radian mode and not in degree mode. Otherwise, you're not going to get the right answer. So what do we get? 0.85. So that would be our answer for that first one. Well, and let's look. 9 a.m. would be between my 8 and my 10 a.m. Yes? So does 0.85 look like it fits within that data? If we're up at 3.8 and I'm going down to 0.1, does it make sense that I would be at 0.85 kind of somewhere in between those two things? Yeah, which is good because we don't want it to be like way off of what those values are, because again, this model represents my data, so I should get stuff that's pretty close to my data. Okay? Then what do I want to plug in for 3 p.m.? Where did I get 15?
Wait, no. Isn't it 12 hours?
Correct, it is, but also my T's represents time since midnight, right? So because 3 p.m. is not 3 hours since midnight, right? That would be 3 a.m. We technically want to add 12, okay? But like you said, this is repeating in a 12-hour cycle. So even if we plug in 15, I should still get a value that's relatively close to what I would get if I plugged in 3 a.m. Does that make sense? So we can still kind of check ourselves from that spot. So if I look at that, we get 10.55 for 3 p.m. And again, those are depths in feet. Okay? And again, if I look at where 3 would be, notice that we're at 8.7 for 2, and then we're increasing to 11.3 at 4. So 10.55 makes sense to be in between those two things. What question do we have on any of those steps? Because this is a really similar process to what you're going to be doing, except you're going to be doing temperatures instead of depths of the water. Yes, ma'am.
Does it see when you put anything?
Okay.
What do you mean the old value and the value?
So old value meaning the value from our parent graph. Like old meaning like the parent graph is our normal starting spot, right? New value meaning the new data that we have instead. Because basically I'm trying to figure out, well, usually my old spot where I have a maximum is pi over 2. My new spot that I have a maximum is at 4. I'm trying to figure out what C gets me from 4 to pi over 2. However, my period, the B value, does affect that, so that's why we have to put that in there with it. But I'm basically trying to compare where it used to happen and where it's happening now, and figure out how did I shift that to get there. Does that kind of make sense?
Yeah.
Other questions?